What up, what up, what up? Mr. Haddock here, and it's a great day to learn some science. Today is lesson 2.8. We are going to specifically focus on pressure systems. We will also talk about the Coriolis effect as well. Um, let's get started. So the first thing we need to know about pressure systems is we need to just review some basic things about air pressure. So remember, in the atmosphere, as you increase in altitude, the air pressure decreases. The simple reason why is because there are fewer air molecules as you go up in Earth's atmosphere. So there are fewer air molecules as you go up in Earth's atmosphere. The second thing is that air pressure does vary from day to day. And the cause of that, why air pressure varies, is because the sun unevenly heats the Earth's surface. Land heats differently than water. Land heats up much more quickly than water, and this causes a differential in Earth's heating on its surface. The third thing, air pressure depends on only two factors, and that would be temperature and density. And finally, air pressure is measured with a barometer, which is a weather instrument. The first type of pressure system is a low pressure system. This typically brings stormy weather. Low pressure systems are caused when warm air rises, or I should say warmer air. All of these temperatures, warmer air, colder air, are relative. So the warmer air, because warmer air is less dense than colder air, the warmer air rises. Lower pressure is at the center of that area where the warm air is rising. Winds blow towards low pressure, so they blow inwards towards the low pressure center, towards the warm air rising. The winds rotate counterclockwise in North America. So they spin counterclockwise, or I guess you could say to the right, depending on your perspective. They do curve slightly in the northern hemisphere. And low pressure systems are labeled with a red capital L on weather maps. So you can see, meteorologists on the news use the red L to identify where a low pressure system is located at. The second type of pressure system is high pressure system. High pressure systems bring fair weather, usually maybe a few clouds, but no precipitation. High pressure systems are caused when cooler air is sinking from above. High pressure is the most at the center, where the air is the coolest and sinking the fastest. That is where the highest pressure is at. Winds blow away from a high pressure center, and they rotate clockwise in North America, or north of the equator. So it looks like, if you look at the picture to the right, they kind of curve, I guess you could say, to the left. And high pressure systems on a weather map are labeled with a blue capital H. Now, what we're going to do is we're going to talk about why these winds curve in high and low pressure systems. Why does it appear that they curve? And that's simply because of something called the Coriolis effect. You will be watching a video and doing some reading next in this lesson on the Coriolis effect. So I'm not going to go into too much detail here, but just enough for your notes. So the Coriolis effect makes things like planes and air, things that travel long distances, appear to curve around the Earth, rather than going in a straight line. So a plane that's flying from Florida to Maine might look like it's curving. Now, the cause of the Coriolis effect is very simple. The Earth is a globe. It is a sphere, and that means that different parts of the Earth move at different speeds. So the North Pole rotates somewhere around, 0.00005 miles per hour, while a location like the equator travels much faster at 1,040 miles per hour. And that's just a property that spheres have when they spin. So with that, you are done taking notes on section 2.8. You will be learning about the Coriolis effect on the next page, but don't forget to read about high and low pressure systems below this page. Have a great rest of your day. If I don't hear from you, adios.